Okay, so before we start, let's talk about setup that we need for Unix or that you should know. So for this vibe, we will be using the OCI compute, which is provisioned in the OCI Phoenix region. We will be connecting from our local machine using Mac OS, where we will run the lab by connecting over SSH. From there, all Unix commands will be ran on the cloud compute, not your laptop. So I will be connecting from a MacBook in San Francisco, California, in the United States. From there, I will be connecting to a public internet, which has a secure connection. From there, I have from the Oracle Cloud Infrastructure, we have the compute instance, which will allow me to run my commands from the Oracle Linux, which is being located in Phoenix, Arizona, which is located in the United States. So here's just a little visualization of the Oracle Cloud Infrastructure, or OCI, and how it works. Okay. So let me get started. So in this session, we'll be going over.
Sorry to interrupt.
Yeah.
Did you talk about the slide number 2 in the earlier?
Oh, yes. Okay. So let's talk about what is happening behind the scenes. What do we really see? So what happens when you first type in the URL aiforbetterlife.org in the browser? So when you first type that in the browser, its response gets, or not response, it requests to the DNS, which is the domain name system, which then translates the name aiforbetterlife.org into an IP address. For example, here is an example of an IP address. From there, the browser connects that to that IP. So it connects your computer or laptop to that certain IP, where the IP belongs to the OCI compute. From there, the app runs on the compute server, for example, the website or API code. Then the compute will send the responses back to using HTML or its data. From there, the browser will render the website. So a little visualization. So first you type in aiforbetterlife.org. From there, it will send a request to the DNS. You could think of it as a DNS book. From there, the DNS translates the name into the IP. So here's the example. The name turns into an IP. So it's like an internet phone book. So then it will connect to the internet. So using the internet, the browser will connect to the IP. From there, our computer and IP, we will connect to the cloud server. So the application will run on a cloud server using Linux and Unix, the operating systems, where then the IP belongs to the server. So using the data, we will get the API response, and we will see our website. Okay. Okay, so let's begin. So in this session, we will be going over file system navigation. That's our main idea. So let's look at our agenda. We will be going over Unix and Linux basics. We will understand and talk about why Unix matters, mainly for AI and ML. Then we will go over how commands work, the regular expressions, including regex. From there, we will understand the terminal prompt, and we will mainly look at file system navigation. We will go over the wildcards and patterns, some special systems, workspace organization, permissions, and executables. And finally, we will go over some productivity tricks. So these are just a sneak peek of what we're going to be going through today. Okay, so let's talk about Unix and why it matters for AI and ML. So Unix mainly follows the philosophy do one thing, but do it well. So everything is treated like a file. So even devices like GPUs and drives, everything is treated like a file. Um, there's command line first. So what that means is we type in commands all the time. So we don't have buttons, we don't click. We always are typing commands. Unix is simple, efficient, and predictable. It is made for speed and clarity. It is mainly built for engineers and servers, which is perfect for AI and ML work. So you mainly meet Unix or you see Unix in macOS terminal, cloud servers, GPU machines, and DevOps tools. So we are going to be using macOS terminal, which our macOS our macOS already uses Unix. So what is Linux? Linux is an open source version of Unix where it powers almost all GPU machines that is being used in AI. It runs important tools like Docker and Kubernetes. We will be using it when we will use it when we SSH into remote servers. Most real AI models are trained and deployed on Linux. So some common Linux versions include Debian, Red Hat, and Oracle Linux. Most AI systems run on Linux, meaning that it is good that every AI engineer will learn it. So let's look at the big picture. So what are the operating systems? There are two different operating systems. So there's Linux and Unix. So let's look into it. Unix has been developed in 1970s at the AT&T Bell Labs. Some of its characteristics include closed source, so it's closed sourced, it's licensed, very stable and secure, and it is used mainly in enterprises. Some of its Unix variants include BSD family and commercial Unix. We normally use Unix in banking systems, telecom infrastructures, government and defense, and large enterprise servers. So you all probably have known Dennis Ritchie. He's very famous. He is an innovator, and I think he created the C. He created C language in Python, or not Python, in computer science.
He's the inventor of C programming language.
Yeah. So relating to Dennis Ritchie, him and Ken Thompson have created Unix as well. So it was developed at the AT&T Bell Labs. Did you accidentally do this?
I think so. I think so. No, I did not really put it. That's fine. You can ignore.
Okay, starting, let's look at Linux. So Linux has been created in 1991 by Linus Torvalds. Some of its characteristics include it's open source and free, highly flexible and customizable. It has huge local or global community. So some of its distributions include it's Debian based, it's Red Hat based, independent, and source based. Some of its usages include servers and cloud, cybersecurity and hacking, desktops and laptops, mobile phones, AI and ML supercomputers, and embedded systems. And again, it's been created by Linus Torvalds. So let's compare Unix and Linux. So Unix is closed source and it's paid less. It's enterprise focused. It has fewer variants and slower innovation. Linux, on the other hand, is open source, free, used everywhere, has hundreds of distros, and is fast community driven. So a key idea is that Linux is a Unix-like system which is inspired by Unix. So let's compare macOS and Linux using the Unix relationship. So macOS is built on Unix. It's certified by Unix, and it's an enterprise grade core. Linux, on the other hand, is Unix-like, but it's not Unix certified. It's independent and implementation. It has an independent implementation, and it's a community-driven core. Okay, so why Unix matters for AI and ML? So training logs appear in the terminal, not in a GUI window. So datasets are organized using terminal commands, not file explorers. So most GPU machines have no desktop, only command line. So today we'll only be using, throughout the entire Unix, we will only be using commands. So there are AI model files and configs that live in hidden folders. So AI workflows run through CLI tools. Like I said, no buttons, just typing and commands. And the terminal is basically the control room for AI. Okay, so now let's really get into it. So here is the basic command structure. So you could think of this as the syntax. So first we write the command, then the options, then the arguments.